We'd never get any physics done without money. But what happens when you're the person in charge of handing out over £800 million a year? I'm joined by David Delpy, head of the EPSRC, which is the UK's biggest research council. David, we're here at a meeting in Munich to celebrate 25 years of the journal EPL, and you're giving a lecture on biomedical optics. As head of the EPSRC, how do you find time to keep up with the latest research?
I think if you asked my old research group, they'd say that I wasn't up to date on the fine details of that particular research topic. However, there are 168 hours in the week. I do find time and make sure that I do read Science, Nature, New Scientist, Physics World, as many journals as I possibly can. And one of the advantages of being at EPSRC is that I can meet all of these bright young research fellows that we fund, the PhD students that we fund. I visit universities and I'm given a chance to talk to great researchers. And so between them, I probably managed to keep up with a broad overview of research, but as I say, not the level of detail that I perhaps once had in my own field.
You're speaking here in Munich on the topic of biomedical optics. What do you think is the single most exciting challenge in the field?
If I was going to put it into a single sentence, it would be to be able to use light to provide functional information and functional images of the body. We have techniques like magnetic resonance imaging, ultrasound, X-ray imaging, which can provide a lot of detail about the anatomy of the body, bones, organs, and so on. What you really need clinically is to know the function, whether the blood's flowing, what the metabolism's doing, is the oxygenation of an organ adequate. And that's functional information. Light can give you functional information, but it's very hard to get sharp images. And so I would love to, in fact, solve that problem or see it solved. And that would enable us to get as close as possible to the Star Trek tricorder that Dr. McCoy waves over the patients and the lights flash. And although it's a science fiction story, I think light has a great capacity for providing a lot of that information. And I'd like to get as close as possible to that.
Now, research funded by your research council led to Andrei Geim and Konstantin Novoselov winning the Nobel Prize last year for their work on graphene. Let's say I'm a young researcher with a great idea. How would you help to support me?
Well, first I would hope that our peer review mechanism does enable creative and really novel research to be identified and funded. But as part of our focus over the next 4 years, we're going to be identifying leaders, whether they are individual leaders of a discipline or leaders of large teams, and provide them with funding, not just in the form of a one-off grant or a fellowship, but to provide funding across the whole of their research career, to provide mentorship, to provide additional training in the additional skills that you need to be a research leader and internationally competitive. So leadership is a real focus over the next 4 years, and I hope that we'll, in fact, maintain what is already a very good record and build upon that.
Now, there's no denying that you've put in some pretty controversial changes to the system whereby the EPSRC judges which grant applications should be funded, for example, by limiting the number of times a person can apply each year. Do you think that's stifling creativity?
The answer is no, it isn't stifling creativity, and I would also question that this is that controversial a mechanism that we've imposed. The reason for doing it was that success rates had fallen to around 20%. In some panels it had gone as low as 15% because of the increase in the number of applications. We were also having great difficulty getting referees to actually referee that number of applications. So what we said is we would no longer accept resubmissions of grants that had been rejected, and that brought us in line with other research councils, so that's not that controversial. But more controversially, we said if an individual had had 3 applications rejected and rejected in the bottom half of a panel's ranked list in the last 2 years, they would be limited to 1 application in the next year. Now, this is a judgment that the peers, the academics' peers, are making of the quality of the applications that are coming in. Having imposed this on the community, success rates have now gone up to about 30% because the number of applications has dropped. we're seeing an increase in the number of referee responses, and we get our panels to look very carefully at whether the applications we're getting are in fact more conservative and less creative, and there's no evidence that that is happening, or that indeed young researchers are being penalised by this mechanism. In fact, the young researchers are doing slightly better than the middle-aged and more elderly researchers.
All research councils around the world have an urge to set strategic targets so that governments know that their money's being well spent. But do you think that having such targets and asking researchers to explain the impact of their work is inadvertently hampering basic breakthrough research?
I think the quick answer is no. First of all, let's look at what we're not doing. We're not asking academics to predict the full detailed outcome of their research. What we're saying is, when you put in an application and you have some idea as to what it is you're going to achieve, what it's likely to be able to do, start thinking right at the outset about how you would maximise the impact of that bit of research, whether it's within your discipline or in the form of perhaps policy advice to government, or as a product that could be marketed. We want you right at the outset to think about how you would maximise that impact. Ask in your grant application for the resources to do that. I'm giving out £800 million worth of taxpayers' money every year. I think the taxpayer actually has the right to ask the researchers who are in receipt of this to think about how they would maximise the return to the UK, not just financial, but in terms of societal benefit. This is something like 6 or 8 hospitals a year that I'm using to fund research, and I think that's a great thing to do. But I think there is an obligation on researchers to think about how they also then maximise the return to the UK from that investment.
The final question, David. There have been moves recently by the British government to limit the number of people who can come and from outside the European Union can come and work and study in the UK. Do you think this will damage the UK's standing in physics?
I think the answer is it will damage its standing in research in general. I'm very pleased that, in fact, they have put some mechanisms in place which provide additional points for PhDs and for people who have a very high standing in academia. But the reality is that research is an internationally competitive game, and I use the word game because I think it's great fun, actually. But it is internationally competitive. If the UK wants to maintain its position, we have to be able to both attract and to continue to fund the very best people in the UK, enable them to work with the very best people outside the UK, and any form of restriction of movement across international boundaries actually will work to the detriment of that, not just in physics, but in all areas of research.